Hey, welcome to 4-6. One of the things that's really cool about this lesson is it's short. Given the last one, which went pretty long, I'm sure you'll appreciate that. A few questions for you. I hope you've been looking at the mental math questions that occur, because some of these are really good in terms of just kind of preparing you for things that are coming. And in this case, it's asking how many cups are in 2 pints, how many cups are in 2 quarts, and how many cups are in 4 gallons. This kind of requires that you know the conversion factors. I'd suggest if you're not sure about it, go take a look in Miss Jennifer's room. Up on the wall, there's a little like an embroidery kind of thing, a pattern for an embroidery that shows you which one is which and how they relate to each other, and it would allow you to do this yourself. So the idea in this situation is that it either always happens or it never happens, and we've got two jobs. One that starts at a salary of $30,000, and another with a starting salary of $28,000, and then they both have yearly raises of $5,000. It's pretty clear if we're going to take these jobs, we'd take job one because it's always going to pay more. And indeed, if we look at it in a table, we see that job one is always greater than job two. And if we graph it, we see that that's true as well. And this is a situation where they never happen. It never happens that the two jobs are in the same money. And one of the ways we can see that is if we run through this equation here, where on this page here, and we have the two expressions, and we compare them. We show that job one is greater than job two. Then, with that information, we can solve this for n. We subtract 5,000n from each side and collect like terms. Well, 5,000n minus 5,000n is 0. 5,000n minus 5,000n is 0. And I'm left with no variable. And $30,000 is greater than $28,000. The variables disappeared. $30,000 is always greater than $28,000. What this has told us is that if n is any real number, then $30,000 will always be greater than 30,000n will always be greater than 28,000n if we put these two together. So it just doesn't matter what n is, it's always going to be true. So when we look at this, solving a sentence, if you get a sentence that is always true, then the original sentence is always true. It's always true that job one pays more than job two. Now we look at it again. We want to know, when does job one pay less than job two? And now we're putting it in as job one is less than job two and solving that inequality. And we get a statement that tells us that 30,000 is less than 28,000. This is never true. So that means that job one never pays less than job true. And here's the other statement: sentences that are never true. When solving a sentence, if you get a sentence that is never true, then the original sentence is never true. So we've got these two statements that help guide us. And so if we solve it, we get something that's true, then it's always true. If we solve it, we get something that's never true, then it's never true. Okay, we've got a couple of examples. I'm going to go through some. The guided example, I think, is pretty straightforward. Let's see what you think. We'll do it right now. What are we going to subtract? When we subtract 42k from both sides of the equation, what do we end up with? Well, 42k from 42k is just 0. And 42k minus 42k is 0 plus 6, and we end up with 6 is greater than 0. 6 is greater than 0 is always true. Therefore, the original statement, the original sentence, is true for any real number k. We could graph this and check it. You can see from the graphs that they appear to be parallel lines. Under questions, we got covering the ideas and applying the math. Work through it, prepare for your mastery quiz. I think you'll find this one will go pretty quick. Have fun with it, and see you in time for the quiz. Hi, this is extra example 1 for 4-6. Our first problem is to solve 7x minus 10 minus 3x equals 2, and then in parentheses, times 2x minus 4. So we'll set about working on how to resolve this, and this is our normal case. First thing we're going to do is simplify this by combining like terms and then using the distributive property to expand the multiplication in the parentheses. So my first job is to turn this into an addition problem by using the algebraic definition of subtraction, because that allows me to move things around without worrying about how things might go together, and I might as well do this expansion. So that'll be 4x, 2 times 2x is 4x, 2 times minus 4 would be plus a negative 8. Okay, so 2 times a negative 4 is a negative 8. I made that addition. So now we can move this, and 7x minus 3x is 4x minus 10 equals 4x plus a negative 10 plus a negative 8. Now I'm going to go ahead and subtract 4x from both sides of the equation, and 4x from 4x is just 0, right? Minus 4x minus 4x, that'll be 0, plus a negative 10 equals 0 plus a negative 8, and we end up with negative 10 equals negative 8, which is not true. Therefore, the original statement, the original sentence is not true. So we've come to a conclusion that can't possibly be true, and we can reach the conclusion the original sentence was not true. Our next one is we're going to solve this 7q plus 1 is greater than 60q minus 4 minus 53q. So first thing we want to do again is combine like terms. So 7q plus 1 is greater than 60q minus 4, how about plus a negative 4, plus a negative 53q. Now we can move stuff around. So 7q plus 1 is greater than 60q minus 53q is 7q plus a negative 4. We subtract 7q from both sides of the equation. And 7q minus 7q is just 0, so I get then that 1 is greater than a negative 4. This is in fact true and is always true. Therefore, the original sentence is true for any real number q. That's it for examples for this one. I really don't have much more to go through. Good luck on the mastery quiz. Hope things are going well for you. Remember, come in, get involved in some discussions, ask questions, make sure you know what's going on.